In the previous video, I talked about the various ways in which you can create routing patterns that map URLs to the controller actions in your site. In this video, we'll explore a few ways that you can make your routes both more and less forgiving of what URLs they match with. We'll begin by taking yet another look at ASP.NET MVC's default route. So far, we've been concentrating on the second line, the URL pattern. But what about that third line? I mentioned way back in the beginning of the course that this third line contains the defaults for the route. But what exactly does that mean? Simply put, whenever you supply a default value for any placeholder in a route, that placeholder becomes optional. In other words, the routing framework is free to match the route to a URL, even if it does not match that particular segment of the URL pattern. That is how the framework is able to match the root of our site, the site's homepage. It simply falls back to using all of its default values, the index action on the home controller. The URL parameter.optional default value for the ID parameter is kind of a fake default. It just means that it's okay for this parameter to be completely left off, and if it is, no default value will be supplied for it. This combination of such a universal URL pattern and a forgiving set of defaults creates a very powerful and flexible route that can match just about anything you need out of the box. Here are just a few examples of the practically infinite list of URLs that this pattern is able to match. Now that we've seen how to use route defaults to make our URL patterns more forgiving, how do we achieve the opposite effect? In other words, how do we restrict the URLs that match our URL patterns? For example, what if we want to use the default controller/action/ID pattern, but we only want to allow the ID parameter to match purely numeric values and ignore all others? The answer is URL routing constraints, and they are as easy to define as adding one more line of code to your route definition and writing a regular expression. What I'm referring to is one more optional parameter that the map_route method exposes, which allows you to set constraints on the placeholders in your route. Much like setting the default placeholder values, you create constraints on your route by creating a new anonymous type and populating it with the properties that match the names of the placeholders that you want to constrain. Therefore, we can apply the numeric constraint mentioned above by adding this line. With this constraint in place, here are a few example URLs, some that match and some that don't. Notice how the regular expression we used matches 0 to many digits, which still allows the ID to be omitted completely. If we change the regular expression to require at least one digit, the constraint overrides the default ID value, and this route becomes much more limiting. One more scenario that you may end up needing in your application is to embed something like a date in your URLs. For example, here is a route definition that exposes blog posts based on the year and month that they were posted. Here we're constraining the year and the month placeholders. We're requiring the year placeholder to have 4 digits and the month placeholder to have 2. No more, no less. With these constraints in place, take a look at this list of URLs, some of which match the root and a few that don't. Using regular expressions to define constraints gives you an immense amount of power over the placeholder values your routes will accept. If a constraint is not met by a route, the routing engine considers that route not to be a match and continues enumerating through the routing table, looking for the next matching route. Knowing this, you can actually use constraints to help you resolve scenarios where you have identical route URLs that you want to resolve to different controllers or actions. For example, here are 2 routes that use identical URL patterns, but apply different constraints to match 2 completely different sets of URLs. Finally, though it's outside of the scope of this course, it's worth noting that if you aren't able to express your constraints with regular expressions, you can apply custom logic to your routes by creating and registering a class that implements the system.web.routing.iRouteConstraint interface. In addition to defining routes that map to controllers and actions, ASP.NET MVC also allows you to define routes with URL patterns that it should simply ignore. The routing framework exposes this through the ignore route method, which adds a special route that tells the routing engine to ignore requests for any URL that matches a given pattern. Consider the following snippet from the default routing logic that Visual Studio generates, which instructs ASP.NET MVC to ignore routes that contain .axd, the file extension used for common ASP.NET handlers such as trace.axd and webresource.axd. With this call to ignore route in place, requests for these URLs are ignored by ASP.NET MVC and handled instead as normal requests to ASP.NET. You can use the ignore route method to ignore other requests as well. For instance, consider a scenario in which a section of your website contains code written in another framework or language that should not be handled by the ASP.NET MVC runtime. In this case, you might use something like the following snippet to tell ASP.NET MVC to ignore URLs that start with php-app. Note that if you're going to use the ignore route method in your application, it's important to place calls to this method before adding standard routes via the map route method, so that the ignored routes get matched first. This concludes our whirlwind tour into the inner workings of the ASP.NET routing engine. With the tips and techniques I've shown in this chapter, you should be able to map your controller actions to just about any URL you can ever think of.